Okay. So time value of money, that is chapter 5 in your book. Is there anyone who can tell me what we mean by time value of money? Just a rough idea.
I'm happy just to throw something out there for the group. So I guess in my mind, money, depending on when it's referenced or when it's looked to be used, can have a different value, whether if it's future or past. And even just thinking about inflation and the society that we live in today, again, a dollar isn't as worth as much as it was 10 years ago or 5 years ago. So kind of thinking along those lines.
Exactly. I think that's a perfect explanation of the concept of time value of money. So, as you said, a dollar today is better than a dollar tomorrow, because if we don't use the dollar today, this dollar is going to, the time is going to erode its value. And that's why we call it the time value of money, because money's value is related to time, and it depreciates, it loses its value, its purchasing power with the passage of time. And Zach, as you mentioned, like one of the key important variables is inflation. So if nothing else happens, only inflation is affecting the time value of money. You're losing, like these days, what is the inflation rate? Like it's 7-8%, right? So if you've got $100,000 in your bank account today, and the same inflation rate continues, the value of your $100,000 is going to be 8,000 less in a year. So it's better to invest it and earn some interest, which can compensate for the inflation, and it can also earn you a return. So that is the primary concept here. Okay, if there's any question, just jump in and ask your question. Or I would be very happy if you also participate in the discussion. So that's the thing. Money loses value with the passage of time if not invested at a particular appropriate interest rate. Okay. And when we make an investment, we take the following factors into consideration. So what rate of interest or what rate of return is an appropriate or desirable return for us? So one thing that we would like to consider is the interest rate. We would like to invest our money at a rate of return which should at least be equal to or more than the inflation rate. If it is less than the inflation rate, then we are actually, we will be getting a little bit of return on our investment, but even then we are losing our value. So for example, if the inflation rate is 8%, and we find an investment opportunity that gives us a return of 8%. What do you think are we earning in this case? Are we earning anything?
Not necessarily. Wouldn't you just be staying basically neutral?
Correct. We're just neutral. We're just maintaining the dollar value of, the dollar amount is going to be increasing, but we're just maintaining the value of our money. At the end of the year, we'll have 108,000, but that's just equal to 100,000 today, because we just earned the inflation. So inflation did not erode our money. But if we invest our money at more than 8%, let's say 15%, then in that case, we are earning 7% above the inflation rate. So that 7% is going to be our real return. Okay. What if we invest our money at 5%? We found an investment opportunity that gives us a 5% rate of return. In that case, we are getting 5%, but in fact, because the inflation rate is 8%, we are still losing 3% on our investment. So in that case, we have got a negative real return. Our real return is negative, even though our nominal return is 5%. Okay, the other factor that we would like to consider is the risk of the investment. So that's inflation is not the only factor. Why do we not invest in most cases? Because we are afraid of losing our money. Okay, and the more risk you take, the higher return would you be expecting from that investment. Otherwise, you wouldn't be making that investment, and still you would be willing to accept that risk. So risk and return go hand in hand. That is the reason that when you go to a bank and apply for a loan, for example, the interest rate is different for different people. The reason being the inflation rate and the interest rate in the market is the same, but because every individual has a different credit score, and based on the credit score, the bank will determine the level of risk it is taking, and it will determine the interest rate. So it's going to be different for different people because the bank in that case is taking different levels of risk. And we talked about real rate of return for us. Like, so the real rate of return, if inflation is 8% and we invest at 5%, real rate of return for us is minus 3%. But if we invest at 10%, then the real rate of return is 2% for us, because that 2% is going to go to our pocket. And we also need to include the risk of the investment, which we were going to talk about in more detail in a later chapter. Okay. Now, what we're going to learn in this chapter, we're not going to cover everything. So it is very important, even after the class and after watching all the videos, that you read the chapter, okay? Very important. There's no exclusion. Your book is a very important resource for the course. So it's important that you read the book. So we will calculate future value. So what we mean by that, if you have got a certain amount of money, as we said, like $100,000 today, and you invest that money at a certain interest rate for a specific number of periods, what will be the future amount that you will get? So we'll be calculating the future value in that sense. And then we will also calculate present value. Okay. So present value would be if you've got a future, if somebody promises to give you a certain amount of money in the future in return for you to make an investment today, and that future amount is, like, let's say $100,000 or $150,000, what would be its present equivalent? That's what we call the present value. And there will be certain situations where we know the other variables, but we will be calculating the interest rate that is embedded in that particular investment. So we'll calculate the interest rate. And also, there will be some problems where every other variable is given, but we will be calculating the number of periods or the number of years it will take for our investment to reach from one level to another level in certain in a certain number of periods. Okay, we will then also calculate present and future values of annuities. Have you ever heard of annuities?
Yes.
Okay. Can you say a little bit about that?
Unfortunately, no.
Okay, well, it's good enough that you heard about it. So we'll be talking in more detail about annuities. So annuity is basically,
isn't that when you can kind of get your money now that you invested? It's like you get the return on investment ahead of time versus later. Is that kind of what annuity is?
Well, that is the basic concept is the same as you said, but the structure is going to be slightly different. So in case of annuity, you probably make an investment today, and you will be receiving the return in equal installments over a certain period of time. Okay. So that could be like, you receive a monthly, like, let's say, you make an investment today, and then you will be receiving a monthly income from your investment until like 5 years or 10 years. That would be annuity. So the concept is the same, but the calculations are going to be slightly different. But don't worry about that right now. We will discuss this in detail in this chapter. Okay, and then we'll talk about the effective annual rate. Now, this is a very important concept to understand because you know the interest rate that a bank quotes to you. Let's say you go to a bank and ask for like a certain amount. They say, well, the interest rate is 10%. Okay, 10% nominal rate. But then the bank says, well, okay, that's fine, but we will be doing compounding on a monthly basis. And in effect, when you calculate the actual interest rate, it is going to be more than 10%. And that extra, the actual interest rate is what we call the effective annual rate. So we'll have some interesting calculations on that as well. And the last concept we'll be talking about is amortization. So this basically is for a loan situation. When you borrow loan, it could be a mortgage or your car loan or any other loan. You borrow a certain amount of money and you are paying it back in the future in equal installments. Okay, so how do we calculate those installments, and how much of that installment is going to reduce your loan, which means that is going to your principal, and how much of that is going towards interest, which becomes an expense. So that's going to be an interesting discussion as well. So these are the few topics we'll be talking about. So the first one, calculating future value. All right. So here's a situation for us. And the situation is, what is the future value of an initial $100 investment after 3 years, if you're making this investment? And the I divided by YR, which means like interest amount per year. In other words, that's the interest rate. The interest rate is 4%. You are making this investment at 4%. What will be the value of this investment after 3 years? So in other words, if we draw the timeline, we've got this $100 today, and we will invest this at 4%. So this is the end of year 1, end of year 2, and that will be the end of year 3. When we reach this point, we will receive the total amount, which includes our principal of $100 plus the interest that we earned over this period of time. So what is your guess? What will be the total amount that we'll get after 3 years if interest rate is 4%?
I can tell you after the first year, you'll have $104.
Correct. After the first year, you will get $104 because you invested 100 and 4% interest rate, so you will have 104. So that's a correct answer. Fantastic. So can we add $4 for each of the next 2 years?
112.
112. Okay, that is Vivian. Thank you. Do you agree with 112?
I don't think so, because wouldn't you would after the first year, your new amount would be $104. So then you take 4% of your 104.
Exactly.
So it's 113.2.
Yeah, something like that, but it's going to be more than 112 because that is what we call the compound interest. Because when we reach to the end of year 1, how much do we have? Let me see, my pen was not working. Let me see if I can still draw here. Okay, so at this point, we will have $104. So for the next year, we will be earning 4% interest on the $104. So of course, $4 for the $100 and then something extra for the $4. And then this will be like, you know, something more, and then it goes on. So what that means is that in the second year, we are earning interest on our 100% principal investment plus we also earn interest on our $4 interest that we earn. So that is why we call this compound interest, because we earn interest on interest that goes on, and that is that has a phenomenal effect. But nothing to worry about. We've got a simple formula to do this calculation. The formula for calculating that future value would be equal to, if we call this future value as FV, and let me write a small n with this, which means like future value after n number of years, any number of years. The formula would be equal to the present value, what we have got invested, okay, multiplied by Okay, let me write it down here. Okay, so our future value after any number of years, in this case, n is 3 because we are investing for 3 years. That would be equal to the present value, which in our case is $100. And this is multiplied by bracket start 1 plus the interest rate, whatever rate you are making this investment in. In this case, it is 4%. Raised to the power n, that is the number of periods. So you can use this formula to find the future value of any investment. Now, the thing here is that you make an investment today and there will be no other payment between now and the maturity of the loan, okay, or the investment. So there will be no payment, no interaction between year 0 and year 3. First investment at year 0 and you receive it at year 3. So there will be no other payments, okay? Now, using this formula, what will be the future value? The future value would be equal to the present value, which is $100, multiplied by 1 plus 4%. So 4% is going to be equal to 0.04. And this is raised to the power n, and that n is 3. Now, can you use your calculator to find this future value?
I would think yes.
Yes.
Okay, that's not going to be a difficult thing to do. But because we are in finance, so we are not going to use a traditional calculator to do the complicated, it's not complicated, but, tedious calculations. We can use a financial calculator to find the answer for us. Okay, so let's pull out our financial calculator. By the way, have you got this financial calculator?
No.
Yeah, yes, I do.
Okay, all right. So this is a BA2 plus professional. You can also buy the normal one, not the professional, but professional has more functions. And it's very useful in finance. You can also download a financial calculator on your phone. There are different applications available, which would do pretty much the same thing. The only problem with that would be that you will not be allowed to use your phone during the exam. So that's going to be a disadvantage. So now let's use our financial calculator to find this future value. Now, when we use our financial calculator, we give it a number of variables. The first thing that you would do with your calculator is to clear the screen so that the data is deleted. And we know the present value, all right? How much is the present value in this case? That's $100. We have got a button for present value, which is this button, okay? Can you see my mouse on my calculator?
Yes.
Okay, fantastic. So the way we're going to do it is that we will type 100, okay? And then we press the PV button, and it gives the tells the calculator that this number is the present value. When you see that arrow that appears over here on the calculator, that means the number has been recorded, okay? This has been assigned to the present value. And then we will give it the number of years or the interest rate, whichever you want to give it. So let's give it the number of years. Number of years is 3. So we click the 3 button, and then we click the N, which stands for the number of periods. So when we do that, the 3 is assigned to the number of periods. And then we have the interest rate, which is 4%. Now, what we do here is that we type 4. In this calculator, it is important to understand that we do not give the interest rate as 4%. We don't give it as 0.04. Otherwise, it will take it wrong, because the button for that is interest amount per year. Okay. So that means like $4 per $100. So that means like this 4 is already by the nature of this button is the interest rate. So we write the 4 interest rate and then click this I by Y, which is the button for interest rate. We click that and it is assigned to it. Okay, now that's it. We then click the compute button. All right, and then the FV button, which is for future value, FV, and we there's something wrong. It shouldn't be that much. So let's redo it. Let's reset everything, because there's the problem that happens with it is that there is sometimes saved data in the calculator. So we press the second function and reset and then enter. It clears everything up. All right. So again, starting again, 100 is present value. 3 is for the number of years. Okay. 4 is for interest rate, which is I by Y. And then we compute future value. And that comes out to be 112.49. Now you can see the 49 is the effect of the compound interest. Otherwise, it would be 112, as we previously guessed. Any question on this?
No, but I do have a related one. On my calculator, I have it set up with 4 decimals. Is that okay?
Yeah, that's even better.
Okay.
Because you will not be missing anything. The more decimals you have, the more accurate answer you will get. All right. Okay. Now, can you tell me, like, there's a negative here. What does that mean here? Negative number. Okay. This is negative because we gave this present value as a positive value to the calculator. So that means if we give it a positive 100, which means positive money means we received the money, right? That means we got the loan. We got the money in our pocket. And at the end of the period, the three years, we will be paying it back with the interest. And at that time, it's going to be a negative value because it will be a cash outflow. So that's why it is giving us this number as a negative number. If we give the initial $100 as a negative number, then the answer is going to be positive. So the calculator understands that, hey, either you invest today and receive it in the future, or you receive it today and have to pay it back in the future. Okay. Now, if you don't have a financial calculator, nothing big to worry about. You can still use Excel, and I'll be giving you access to Excel in your exams as well. Okay. So the way we're going to do it in Excel is something like this. Let's write down the variables. We know the present value, so PV is equal to 100. Okay. And then we also know the number of periods, n is equal to 3 in our example. And we also know the interest rate. So let me call that rate or interest rate or I by Y, whatever you call it. That is 4%. Now in Excel, remember, we have to write it as 4%. Because otherwise we're not going to get the correct answer. Okay, so what do we need to calculate? We have to calculate the future value. It is very easy in Excel. You will have to type the formula. Does anyone know the formula for calculating the future value?
It's the current value, 100.
Okay, yeah. So the way we do it in Excel is that
Oh.
Excel has built-in formulas for doing these calculations. Okay, so we start the formula with an equal, and when we type the equal sign, it means Excel understands that we are now giving it a formula. Okay, and what that formula is, it is called FV. That is the future value formula. and then you will start the parentheses. As soon as you start the parentheses, it is suggesting you to give some variables. Okay, so the first variable it is asking for is the rate. And we know the rate is 4%, so we click on the 4%. And then we enter the comma. And when we do that, the next variable is highlighted, which is NPER. That stands for number of periods. In this particular case, the number of periods are 3, so we click on that cell. Then comma, it is asking for a payment. Now remember that payment in this particular case means that if there is a payment in between, like if you are paying in monthly installments, right, then that monthly installment would be the PMT, that would be the payment. But because in the given example, as I told you here, there's no payment between year 0 and year 3. So there's no interim payment, and that's why we give that PMT as 0, okay? And then comma, it is asking for the present value. And we know that the present value is 100, so we click on that cell. All right. It is also asking for another variable, which is called type. And remember that we will need this type variable when we calculate annuities, okay? You can either, for now, you can either ignore it or you can use type 0. This type basically means that whether the payment is taking place at the beginning of the period or the end of the period. So because the final payment is taking place at the end of year 3, this is, at the end, so we can simply ignore that, or we can give it a 0. When you type the comma, it shows you 0 means end of the period. The payment is taking place at the end of the period. So we either type a 0 or simply ignore it. And then we close the bracket and we are good. Enter, and we got the answer, which is the same number that we got from the calculator. Is that clear?
Yes,
Yes.
thank you.
Okay. And you can see like this number in parentheses and in red color. What does that mean in accounting?
It's a negative number.
Negative.
Yeah, that's a negative number. And it's the same concept. Our calculator also gave this as a negative number to us. Now, and that means that we received the $100 in the present today. If we make this 100 as negative, which means we are making an investment, that is a cash outflow, then the future value will be positive, as you can see, because we will then be receiving the money if we make the investment. Clear? Now with Excel, the good thing is that, well, you can you can use the same formula to let's say there's another problem calculating future value, okay, with different numbers. Okay, let's say there is this amount of money that we borrowed, and we borrowed this for 10 years. Okay, what will be the future value at 4% interest rate? You can see that's going to be 36,365.16. So you can simply, because this formula is linked with these numbers, it simply updates the answer for you. So just in case you need it in the future, in the exam, let's say you typed in a formula for calculating future value in one question, you just leave it right there, okay? And then when you need another formula for, let's say, a present value, you do it somewhere else, so that in that case, just in case there's another problem that asks for calculating future value, you have already built that. Make sense?
Yes, thank you.
All right. Okay, now let's move on to the next topic. So here's the formula, like, the general, if you have to calculate the future value after 1 year, then this is 1 and the power is going to be 1. 2 years, the power is going to be 2. 3 years, power is going to be 3. Any number of years, the power is going to be that number of years or number of periods. So that's the general formula, which is nothing complicated in this case. And here are the buttons for the calculator, which we just did. And that is the formula that we use in Excel, right? So we're all good with calculating future value. Now, what if we have to calculate present value? How do we do that? Okay, now present value. Okay, that's Control Z. Okay. So we know that the formula for calculating future value is FV is equal to present value into 1 plus the interest rate raised to the power n. We can simply rearrange this formula and find the formula for present value. Can you do that for me? What will be the formula for present value?
Present value equals future value divided by the parentheses and the n.
Correct. Fantastic. Thank you, Zach. And then divided by, because we take the 1 plus r raised to the power n to the other side, and it goes to division. So 1 plus r raised to the power n. And so then you can use the numbers and find the present value. And what that means is that if somebody promises to give you a certain amount of money in the future, okay, and you want to know how much should you invest for that investment. Okay, so what is the present value of $100 due in 3 years and same interest? So the same problem as we had before, but the only difference is that we will receive this $100 in the future after 3 years. So you want to know how much should you give this person today so that that investment is equal to $100 3 years from now. Okay, same concept. Let's go for the calculator method first. Okay, here is the calculator method. Go to your financial calculator, and we can simply clear the screen, or in order to be on the safe side, you just reset it. Second function, and then you see the second function of this plus minus button is reset. So we click on this, and then I just say, it is asking, do you want to reset? I say yes. So every stored data is cleared from the calculator, and you will not get a weird answer as we got on the first time. So let's start feeding the variables. So 3 goes for n, number of periods are 3, so we type 3. And there is no restriction on which variable you give first. It doesn't matter if you give the interest rate first, or the future value, or the number of periods. It doesn't matter, okay? So 3 is n, so I type 3 and then n, that is recorded. And then this I by year, that means the interest rate. So that would be 4 goes for I by y, that is the interest rate. PMT is 0. You can either give the PMT as 0, or you can simply, if you don't give that PMT value, it still understands that the PMT is 0. Okay, but let's give it. Okay, 0 goes for the payment. And remember, do you remember that payment means if there's a payment in between, like if it is an annuity, then that would be the situation. Okay, we don't have that situation now. So PMT is 0 and future value is 100. So we type 100. Okay, and that goes for future value. What we need to compute is the present value. So we click on the compute button, and then on the present value button, which is right here, and we get $88.90. Now, what that means is that if you buy this investment at $88.9 and you receive $100 in 3 years, that would mean you earned a 4% interest rate, compound interest rate over the 3 years of your investment. Make sense? And that 88.9 is negative because we are making the investment. Now we can use Excel for the same purpose, but the function is going to be PV function. So let's go back to Excel. All right. And so let me copy this data. copy and paste it here. So instead of PV, we now know FV. FV is 100. Number of periods is 3, and interest rate is 4. We calculate present value, right? So present value, what do? We start with equal sign, equal, and we type PV, which stands for present value. We start the parenthesis. It is asking for the rate, which is 4%. So we click on that cell, comma, number of periods, which is 3. So we click on that, comma, payment, which would be the annuity payment, the equal payment, which is in this case is 0. So we type a 0 over there. Now remember, in the calculator, if you ignore it, that is fine. But in case of this formula, you'll have to give that value. So payment is 0. And then it is asking for the future value, which is 100. Okay. And as I said, for the type, you can either do comma 0, or you can simply ignore it and close the parenthesis. All right. It assumes that, oh, that's fine. So we get 88.9, which is the same answer we got from our calculator. Any question on this? Do you want to try it on your computer to just make sure that you also get the same numbers?
Sure, thank you.
All right, go ahead. And if you don't get the correct answer, let me know. Let me also pause the recording. Recording. Okay. If there's any question, just stop me and ask a question. All right. Now, the next topic would be the interest amount. Okay. Now here it will be an interesting situation. Let's say somebody approached you and say, hey, you know what? If you make an investment of $100,000 with me, I'll give you $120,000 in 5 years. And $120,000 would maybe, like, you see, you think that's a $20,000 profit, which is good. But then you'll be thinking, hey, like, what rate of interest is this person offering me in this case? And is that a rate of interest better than the market? Is that return better than the market, or maybe worse than the market? What if a bank can give you a better rate than that? Then you would prefer to invest your money in a bank rather than giving it to someone to invest in a business, because in that case, it is more risky, right? So you would like to know whether that interest rate is something attractive to you or not. A very simple example is given here. What annual interest rate would cause $100 to grow to 119.1 in 3 years? So what that means is that you invest $100 today, and after 3 years, you will receive $119.1 in 3 years. So what is the embedded interest rate in this investment opportunity? We are trying to calculate the interest rate. So simply we go to our calculator, and in this case we can use the clear screen button. But there's another thing, like there's a cash flow. Whenever we use this cash flow button and we give it some information, in that case it is best to reset it, because the cash flow data will be saved in that case, and that's why we'll get a wrong answer. In this case, just a clear screen is fine. So what variable do we know in this case? We know the number of years, so that is n is 3. This 119.10 is future value. This 100 is present value. Okay, and what we don't know is the interest rate. So let's feed in the data. 100, and this doesn't matter which sequence you use. Okay, okay, let's start it from there, or whatever. Let's start from the future value. So we type 119.1 Okay, and we call this the future value. Now remember, and it is very important in the case of these calculations, whenever you solve a problem where the present value and future value both are given as variables to the system, then one of them must be negative. Otherwise, you will get a wrong answer. You will not get it. You will get an error, in other words. And the thing is that like the calculator gets confused. Hey, how is it possible that you receive $100 today and you also receive $119.1 in the future? That would be something magical that can happen. Otherwise, if you receive it today, you will be paying it back in the future. So one number has to be negative. So let's make the future value positive, which means we'll be receiving that. That means it is an investment. And then we give it the 100. So 100, and we have to make it negative. So we click this plus minus button and then press the PV button. So present value is negative 100. And then we give it 3 as the number of years. So 3 is N. You can give it the PMT as 0, or you can simply ignore it. It doesn't really matter. If you don't give it that, it assumes that it's a 0. We compute, what do we compute? The interest rate, and the button for the interest rate is I by Y. So compute I by Y. So we click compute and I by Y, and that gives me 6%. That 6 basically is 6% because this is I by Y, interest per year. Make sense?
What's the formula for that, like without using the calculator or Excel?
Fantastic, fantastic. In that case, it will become a little more complicated. So let me give that to you. Let me start a new. Okay. And delete this. Okay, so the formula would be, let me also delete this. So we use the same formula. We start with future value. Future value is equal to present value into 1 plus R raised to the power N. Because now we need to find R, we have to bring it alone to the left side. So we can rearrange this formula like this. 1 plus R raised to the power N would be equal to future value divided by present value. Make sense? Okay, now we have to get rid of this N. So when this N goes to the other side of the equation, it becomes 1 over N power. It becomes the nth root. So 1 plus R would be equal to future value divided by present value raised to the power 1 divided by N. Okay, now we also need to get rid of this 1. So R will become future value divided by present value raised to the power 1 divided by N, and that 1 goes to the other side of the equation and it becomes minus 1. You got it?
Yeah, I just use Excel.
Yeah. So yeah, you can do it that way as well if you prefer to. And we can, if it were a face-to-face class, we would have done a lot of calculations on this. But I know the attendance in the live session and the online class is not mandatory, and I really appreciate you coming and joining today. So I would not like to bother you with so many things, just the important stuff. Okay, but if you want more details in anything, just stop me and I'll be happy to give you more details. Okay.
Quick question. Is 1
Sure.
over N minus 1, or the minus 1 is after you solve the The first
Good, yeah, it's after you solve
The first
first
part.
part.
Okay,
Exactly.
thank you.
Yeah, so it will be, you first do the division, future value divided by present value, and
Mhm.
that is raised to the
So
power
power.
of
Mhm.
1/n, and then the answer minus 1.
-1. Okay, thank you.
All right, yeah, thank you. You guys are asking good questions. I'm happy with that. All right, so we can do that with calculator, right? No big deal. Let's go to Excel and see what we can do here. So let's copy the same thing over here, copy and paste. So we know the future value, which is 119.1, right? Let me just make sure. Okay. $119.1, yeah. And N is 3. And we have present value is 100. Now we can calculate the R. So let's write the formula for the rate. N is 3, right? Yes. So the formula for the rate is simple, rate. Okay. You start the parenthesis. It is asking for the number of periods, which is 3. It is asking for the payment, which is, you already know, would be 0 because we're not using any payments in between. It is asking for present value, which is 100. And it is asking for future value, which is 119. And we can ignore the type and guess. Even then, if I close the parenthesis and enter it, I'm going to get an error message. Let's try. Yes, that hash num means that there's something wrong with your formula. What do you think would be the reason?
The present value wasn't positive.
Exactly. We are giving future value and present value both as variables, and the answer is based on those variables. One of them must be negative. Otherwise, it's impossible to receive 100 today and also receive 119 in the future. So let's make this negative. That means we're making an investment. So then you get 6%. Make sense? What if I make both? What if I make both negative? I will still get error message. Both cannot be negative. So let me make this positive and the future value is negative. What that means is that I am borrowing $100 today and I'll be paying 119.1 in the future. All good?
Yes, all good, thank you.
All right. Okay, fantastic. Now let's move on. The next problem would be, what if, all the other variables, but you don't know how long will it take for that investment. Somebody comes with a very lucrative and investment opportunity, like, he's convincing person. He say, you know what, if you give me $100,000 today, I will double it for you at 10% interest rate, for example. Would you be happy with that? If I give you this offer, if you give me $100,000, I will double it for you at 10% interest rate. Would you be happy?
From face value, sorry. It sounds like yes, that would be a pretty good deal.
Okay, good. Thank you, Zach. Anyone else? Any other idea?
I don't know, to double it, it would seem it would take a while.
Oh, yeah, that is the thing here. I mean, like, what if I say, well, okay, if you give me 100,000, I'll double it for you at 10%. Well, I will come back after 50 years. Are you happy with that? No, you would like to know how long is it going to take? If I say, well, I'll double it for you in 1 year, seems like a very good investment opportunity, but probably a Ponzi scheme, right? So anyway, if the interest rate is 10%, how long will it take? You want to know that. In that case, what we give to the calculator would be the other variable. So we clear the screen. We know our interest rate is 10%, so we give 10 as the interest rate. We remember that we don't give this 10 as a person because it is already I by Y, right? So interest rate is 10. Present value, if it is like $1, it would be $2. Like if it is double, $100 would be $200, no, whatever. Okay, $1. So we write 1, make it a negative, and that would be the present value. So we're making this investment of $1. All right. Payment is 0. We can ignore that, or we can type 0 and write it as payment. Okay. And future value is 2, which would be the double of 1. So we type 2, and that would be the future value. Remember that we've already given this present value as negative number, so we're fine with that. And what we want to find is n. So we can click the compute button and then n. So that gives us 7.27. So that means it will take 7.27 years to double our money. It's 10% interest rate. Make sense?
Yes.
Yes. Mhm.
All right. So you can solve any other problem with the same calculations. Now, another good thing with the calculator is that, well, okay, let's say there's another question. Hey, what if the interest rate is 15%? How long will it take? In that case, what we simply need to do, the rest of the data is already entered into the calculator. So we simply type 15 and assign it to the I by Y. Okay, the rest of the data is already there. So we compute n, and that is going to take 4.96 years. So that means like you don't have to give the rest of the data because it's already stored. That's why we recommend that we clear the screen. And just in case when you use the cash flow register or some of these complicated calculations like the amortization and some other functions, then it is recommended that you reset it. Okay. Now let's go to Excel and see what we can do with this in Excel. Okay, so what we have, present value, future value, we also know the rate, and we have to calculate the number of periods. So present value in our example is 1, or it could be 100 minus 100, whatever, doesn't matter. Okay, we want to double it, so the double would be 200. And rate in this case is 10%, so we write down 10%. Remember, in Excel, you'll have to write it 10% instead of 10. And n would be, the formula in Excel is equal to NPER, number of periods, and you start the parentheses. It is asking for the variables. Rate, 10%. Payment, again, you know that is 0. Okay. Present value is 100 minus 100. Future value is 200, and you can ignore the type. So we close the parentheses and enter it. We get 7.27. And you see there are a lot of numbers, so this number is more accurate because it has more decimal points. All good here?
Yes.
All right.
Yeah, good
So
job.
please go ahead, Vivian.
No, that was not me. I said yes, but someone else.
All right. Okay. all
No,
right.
I was saying I was good to go.
Okay, sure. So are you tired or you want to continue?
We can continue.
All right, fantastic. I love to hear that. Okay. Now, this one, interesting, annuity. And this would be more relevant. So annuity is basically, Zach, you heard about this, and now let's explore it. Annuity is basically a series of equal payments at equal intervals for a specified number of periods. And the good example of that would be your mortgage. Okay, you make your mortgage payment, same payment every month for 30 years, but it is monthly. So how many payments are there? 30 years, that is 360, sorry, how much is that? How many months? Yeah, 360 months, right? So there are 360 equal payments at equal intervals. That is what we call annuity. Any payment which is in that form would be annuity. Your rent payment, or if you receive rent from your tenants, that is also annuity. Okay. But there is a slight difference between the type of payment in a mortgage and annuity. What is the difference? Can you, mortgage and rent? What is the difference? The nature. So in case of mortgage, you make the payment at the end of each month, correct? For your car loan, you make the payment at the end of each month. In case of rent, you receive it at the beginning, or you pay it at the beginning of the month. So that is like advance payment for the rent, right? So there are, in that case, there are two types of annuities. Okay, one is ordinary annuity, which is like the usual. You make the payment at the end of the period. So that would be your mortgage payment, your car financing payment, or your any other loan payment would be ordinary annuity. And remember, this is in our formula in Excel, that is the type 0. Payment is at the end of the period. Okay, that is the type 0. Okay, and annuity due is the type where the payment takes place at the start of the period. So that would be like example is rent payment or receiving your rent from your tenant. Okay, that is annuity due. And in our Excel formula, that would be type 1 because the payment is taking place at the beginning of the period. Is it clear? Okay, so moving forward, this is how it's going to look like. Ordinary annuity, you sign the deal here, borrowing or investing. The first payment will be at the end of the first period, second payments end of second period, and last payment the end of the last period. That is ordinary annuity. In case of annuity due, as soon as you sign the deal, the first payment happens right there. Okay, you go ahead and rent an apartment, you pay your first rent right there. And then the second and the third. So the last payment would be at the beginning of the last period. So the last period is from year 2 to year 3, and that is the payment will take place at the beginning of the period, and there will be no payment at the end of the agreement. So you just walk away and you're good. All right. If you want to learn the formula for calculating the present value of ordinary annuity, that would be equal to this. C is basically the payment. So the cash flow, basically the equal cash flow. Multiplied by, you start this big bracket, and 1 divided by R, which is the interest rate, minus 1 divided by R multiplied by 1 plus R raised to the power T. The T basically here is N. So we can, another version of this formula would be present value of annuity would be equal to, if this is easier for you to remember, that would be equal to payment divided by R, which is the interest rate, and then multiplied by 1 minus 1 divided by 1 plus r raised to the power n. So you can use this formula as well. That would be the present value of the annuity. Okay. You can note these formulas down. It's a good idea to note them down just in case you need those formulas in your exam. But you can also use your calculator and your Excel to do the calculations. Okay. The Excel and calculator formulas are basically the same for these calculations. Okay. So let's say there is an annuity that you will be, a bank is giving you a loan, okay? And the bank officer tells you that you will pay, it's not working. Okay, something is wrong with my pen here. Let me see. It's taking the same format, so that's a little bit trouble here. Okay, so let's say we draw this timeline. So times 0, 1, 2, 3, 4, 5, and 6, right? That would be times period 6. 1, 2, 3, 4, 5. And you receive, or you will be making a payment, or you receive whatever, that doesn't matter. You can imagine your scenario. Let's say $500. This is your car payment. And again, 500 here and here and here, and that goes. The payment is at the end of the period, so that's ordinary annuity. What will be the present value of this annuity? What that present value means is that if the bank, you're applying for a loan and the bank say, okay, I'll buy this, I'll buy this car for you, and you will be making a $500 payment to me for each period, up to 6 periods. You would like to know, like, how much loan is the bank giving me? How much is the current value that I'm receiving? Okay. Or this may be the dealer, like the dealer does not disclose the price to you. Well, say, you know, don't worry about that. You just make a 500 payment for the next 6 periods, and I'll give you the car without disclosing the price to you. So this present value of the annuity is basically the price of the car. How much is he charging you for if you were to pay cash? And of course, you also need to know the interest rate. Let's say the interest rate is 8%. You pull out your calculator, and what is not known is the present value. So you clear the screen. Start with any variable, 8% interest rate. So 8 is I by Y. Okay. Do we have a present value in this case? There is no present value. We need to find that out. Okay. And do we have a future value? At the end of the term, there will be no future value remaining. So you can assign 0 to the future value. All right. And what is this 500? The 500 is the payment. That is the monthly or periodic payment. And what is the number of periods? That is 6. So we type 6, and that was the number of periods. I hope we have given all the variables. And what we want to find is the present value. So compute PV. That comes out to be $2,311. All right. Which means that the price this dealer is charging you if you were paying cash is $2,311. And you will have to think about this investment, this purchase. If you can find the same car with another dealer at 2,000, you would like to go for that because at present, 2,000 cash, that would be a better deal because that's smaller than what this dealer is basically charging you. Any question on that? All good? Okay, now let's go to Excel and create this scenario. So we have an annuity where we know the payment is 500. Okay, and if you are making this payment, for example, then that would be a negative number. It doesn't matter. Future value, there will be no future value at the end. When you make the last payment, everything is finished. So there's no lump sum big chunk of payment at the end, okay? And the interest rate is, in our example, that is 8%. All right. And the number of periods in this case is 6 periods. All right. And the periodic interest rate is 8%. We want to find the present value of this annuity. Present value of the annuity, same present value formula. Doesn't matter whether it's annuity or so, same present value formula. You type equals to PV, and it asks for the required variables. Rate is 8%, so I type that in. Number of periods are 6. Now we have the payment. You see that? This 500 is basically that monthly payment or periodic payment. So we, in the previous example, we used to give that as 0 because there was no periodic payment, but now we have that. And the future value, we don't have any future value because at the end of the contract, there will be no lump sum payment. And for the type, it's ordinary annuity because payments are taking place at the end of the period. So we can type 0 or simply ignore that variable. Close it, and we get this number, $2,311.44. Okay. In other words, if you borrow $2,311.44 for 6 years or 6 periods at 8% periodic interest rate, then you would be making a $500 payment each period. Does that make sense?
Yes, thank you.
All right. Okay, so if we continue, I think we can finish the chapter in maybe in the next 40 minutes or so. Or we can stop here and have another session next week. Whatever you prefer. Oh, there's a chat message. Sorry, I have to leave the menu still. All right, Megan, no problem. Okay, we also have Ethan. Ethan, welcome. When did you join? I didn't see you. Let me see.
Thank
who
you.
else.
I joined a little bit late, but I'm glad to
All
be
right.
here.
No problem. Okay. So do you want to continue?
I can share that for the questions that I had for this particular homework, you've been able to really cover almost everything that I wanted to ask. And to be honest, I was even able to, I think, complete some of the homework during this because you covered the material. So I can only speak for myself, of course, but I'm actually pretty good. So thank you very much for your time, and thank you for reviewing this information today.
All right, I'm happy that it was helpful. And anytime, like I'm available on the phone, on by email. Email is the best way. Just send me an email and we'll find a way to work it out. If we cannot clarify the issues via email, we can have a call or we can have a one-on-one live session to resolve any question, any problem that you guys may be having. So, okay, let's end it here. We'll have another continuing session on this chapter. And remember, we have assigned 2 weeks to this chapter. Reason being that it's a little complicated. Okay.
Great. Thanks again for your time.
Sounds good.
Thank
Thank
All
you.
right. No problem. Always welcome. We'll have another session at the same time next week. Monday, 6 o'clock. Thank you very much for joining the class after work. I know it is hard, but I really appreciate you joining today. Thank you and have a
Thank
good
you.
evening.
You
I'll see you
too.
next
Thank you.
Thank you.
Bye-bye.
Bye-bye.